Significant figures is one of those things in science class that really frustrates students, but I'm going to try to demystify it for you and help you understand just how easy it can be and really how important it can be to ensure that you're getting the correct answers in your science class. In the previous video, which if you haven't watched it, there'll be a link down there at the bottom, I discussed, well, what are significant digits and how are they beneficial in science? Because they really are, right? But now we need to understand, what do we do with significant digits? What do we do with significant figures? Ultimately, we're going to get to this end goal where we find out, we're going to answer the question, how do we round our answer appropriately in science class? And the only way to round it appropriately is to use this idea of significant figures. And we have to be able to count the number of significant figures in a number before we can do the math with it. So let's jump right in. I've got 3 scales up here to try to drive this point home, right? Each balance costs a little bit more money than the one before it. Now, you can see one of them has 3 digits in the number, one of them has 4 digits in the number, and the other one has 5 digits in the number. The one with 5 digits is a really expensive scale. The one with 3 costs way more than it should, but it's not over the top expensive compared to the other one. In other words, the more digits we get on a measuring device, odds are the more expensive it is because it has more precision. It's going to give us a more accurate answer for the actual, in this case, the mass of the object. Now, we have to be able to count significant figures or significant digits to be able to deal with this. Here we go. Scientists, engineers, and mathematicians use this common method, which we call significant figures, to ensure that we all get the same answer. This accounting system means that if you're making something, let's say you're trying to make a new car and you're getting parts that are coming from all over the world, those measurements, those calculations need to be the same no matter where they happen in the world. Significant figures solves that problem. So, we're going to have lots of lectures together if you watch any of my other ones. And one of the most important things you'll learn is if I have a box like this in my lecture notes, it's something that you're going to probably use all year, or in some cases, if you move on into chemistry or physics or other engineering classes, this is information you might need to know, well, forever. So I put a box around that kind of stuff in my notes. I'm going to put these up there. I am going to say them, but you might want to pause the video and get this information down into your notes or whatever you're keeping track of because it's valuable. And over 20 years, I've boiled this into the 2 simplest ways that I can explain this. Here are the rules for counting, okay? Number 1, non-zero numbers are always significant. So that means if I'm trying to count how many digits in a number are significant digits, this thing we're learning about, then if I see anything that isn't a 0, well, that makes it pretty easy. So let's go down to this great big huge number down here. There are 24 digits in this number down at the bottom of the screen. 24. But here's the thing. Only 4 of those numbers are significant figures. Only 4 of those numbers are what we call significant digits that we can use for this rounding problem we're going to try to solve together in the next few slides. So I think you could figure out what 3 of them are already. Based on rule number 1, if we look down there, the 6 and the 2 and the 2, well, that's 3 of the 4 significant figures because of rule number 1. The trouble are zeros. Zeros are the tricky ones, which means we have 3 rules that are going to come up on this slide just to deal with zeros. The first one is trapped zeros are any zeros that are between non-zero numbers, and they are always significant. Here's an example. The number 1001 has 2 zeros trapped between 2 non-zero numbers. So both of those are significant digits. If I was going to count the number of significant figures in that number, 1001, there would be 4, right? The 1 here is a significant digit. The 1 here is a significant digit because of the rule we learned up here. And down here, both of those zeros are called trapped zeros, so they are significant digits. This number has 4 significant digits in it. Oh, or 4 significant figures. They're the same thing. The next rule says all trailing zeros are significant only if there's a decimal anywhere in the number. Doesn't matter where the decimal is. If there's a decimal, then trailing zeros are significant. What are trailing zeros? They're all zeros that come after the last non-zero number. Let's look down here. All of these are trailing zeros because they come after the last non-zero number, this 2. But is there a decimal anywhere in this number? No. Does that mean they're not important? Oh, they're important. Can we just erase them? No, that's not what we're talking about. Significant digits doesn't mean that we just leave digits off that aren't significant. Significant might be a bad word for this, right? We can't just erase. We can't just get rid of. We can't just not care about numbers if they aren't included in significant digits. You're going to see that more coming up, so stick with me. Here are a few examples. If I look at this number and I try to count how many significant digits it has 2 significant digits. The 1 is a significant digit, and this trailing 0 is a significant digit because there's a decimal somewhere in the number. The next one over here has 3 significant digits. The 1 is a significant digit, and the 0 here are both called trailing zeros because they come after the 1, which means they're both significant figures as well. There are 3 significant figures in that number. This one over here, there's 1. These are all trailing zeros, and there is a decimal somewhere in the number, so we have 1, 2, 3, 4, 5 significant digits in that number. Then finally this one. The 1 is a significant figure, but that 0, there are no decimals anywhere in that number, and because there are no decimals in that number, that is not a significant figure. Does that mean it doesn't matter? No, it matters. We don't get rid of it. We're not mad at it. We still care about that number, that 0. It's just not part of the counting system for significant figures when we're trying to figure out, remember, we're going to do math in a minute. And then we need to know, how should we round that number? Well, we have to be able to count how many significant figures are in each part of the number to do the math. And right here, well, we only have 1 significant figure. The last rule, leading zeros are never significant no matter what. Leading zeros are any zeros that come before the first non-zero number. To give you an example, we would not cross those off. I have just put a line through them or a strike through to show that, wait, this is the first non-zero number. So all of these are placeholders. They're important. They're fine. We don't need to get rid of them. We're just not going to count them in significant figures. So here we go. This number has 1 significant figure. Let's go back to this really big number down here, which is Avogadro's constant or Avogadro's number. We said there were 4 significant digits in this number. There are 24 digits in the number, but only 4 significant digits. We said the 6 and the 2 and the 2 are significant digits, and this right here must be the other one because it's a trap 0 in between non-zero numbers. These ones back here, these are all called trailing zeros, and we just learned that trailing zeros are significant, but only if there's a decimal somewhere in the number. This one doesn't have a decimal anywhere in the number, so they're not significant figures. Copy that stuff down. Make sure you have it. Make sure you understand it in your notes, and we're going to put it to use. Best way to learn this is through practice. So if we look at our first number here, we can clearly see that that number, or that digit, and that digit, they're all significant figures because of rule number 1. They're non-zero numbers. It's the zeros we have to be careful with, right? So then we look at this. This is called a trapped 0, and trapped zeros are always significant. We can see it right here. And this is a trailing 0 because it comes after the last non-zero number. Trailing zeros are significant if there's a decimal somewhere in the number. So how many significant figures are in this number? 1, 2, 3, 4, 5, 6. There are 6 significant figures. We go over to this one, same thing. I think these ones are fairly easy because, well, they're not zeros. This one we just talked about is a trap 0. It is a significant figure. This one is a trailing 0. And trailing zeros are significant only if there's a decimal somewhere in that number, and there is not. So we have 1, 2, 3, 4, 5 significant figures in that number. This one, look, all the same things, but the decimal's in a different spot. So we have 1, 2, 3, 4. This is a trap 0, significant, so that's 5. This is a trailing 0, which are significant if there's a decimal somewhere in the number, which there is. So we have 6 significant figures over here. We're good? More practice then. The number 75 has 2 significant digits in it because, well, there's no zeros to have to deal with. This one, same thing, two significant digits. That decimal is just really, it'll tell us some information, but we don't need to worry about it for this part. Again, this has 2, and the 0 we need to worry about. That's a trailing 0. Trailing zeros are always significant if there's a decimal anywhere in the problem. So this one has 3. Let me go back and mark these because I forgot. They each have 2. We come down here, we have 1, 2. Oh, these are trailing zeros, but there is a decimal somewhere in there. That means we have 4 significant digits. There are 1, 2, 3. Again, those are the easy ones. Then we got to look at the zeros. These are trapped zeros, and trapped zeros are significant. So we have 5 significant figures. And in the next one here, we have 1, 2, and be careful. All of these are trailing zeros. Sometimes people get confused and think that only the ones after the decimal are trailing zeros. Nope. All of them after the last non-zero number, which means we have 5 significant figures in this one. Let's keep going. The best way is practice, practice, practice. We've got 1, 2. Oh, this one's questionable because it's a 0. Trailing zeros are significant only if there's a decimal. There is no decimal, so this one has 2 significant digits. This one, same thing. 1, 2. These are trailing zeros, but there's no decimal, so we have 2 significant digits. Quick reminder, the amount of significant digits tells us the precision of the measurement, right? So these both have 2 significant digits. These numbers right here may have been rounded off to a 0. We don't know, which is why they're not included as significant figures. Over here, we've got the 7 and the 5. Let's look at this one. This is a leading 0, and leading zeros are never significant. So we're not going to count that as one of our significant figures. This is a trailing 0, and there is a decimal, so this one has 3. Down here, 1, 2, there's a trailing 0, and there is a decimal, so this one has 3. This one has 1, 2. There is a leading 0, not because it comes in front of the decimal point. It's a leading 0 because it comes in front of the first non-zero number, and leading zeros are never significant, so we have 2. And we get over here, 1, 2. These are all leading zeros like we talked about. They are not significant figures. This is a trailing 0. They are significant figures if there's a decimal anywhere in the number, so this one has 3. Hopefully we're feeling good. 1, 2, trapped 0 makes a total of 3. 1, 2, 2 trapped zeros makes a total of 4. 1, 2, ooh, trapped 0, trailing 0. Well, this trailing 0 is not significant because there's no decimal anywhere in the number. So this one has 4 significant figures. Whoa, this is something new we haven't talked about yet. This is scientific notation. Now, this takes a little extra. In scientific notation, we only worry about the first part of the number. When we're counting significant figures, we don't worry about this. These are zeros and they're trailing zeros, and trailing zeros are not significant. So this has 2 significant figures, but let me show you that. If I take 7.5 and I times 10 to the 4th, you're probably taught that I need to take that decimal 1, 2, 3, 4 places and move it right here, put the zeros in. Now, I'm going to rewrite this over here so you can see it. That would make this number. Now, I can't put the decimal there. The decimal doesn't really exist there. Because if it did, I would have a lot more significant digits than I'm allowed to have. Right? Let's look. Right here, this has 1, 2 significant figures. These are trailing zeros, and there's no decimal anywhere in the number. So right now it has 2 significant figures, which is what it's supposed to have. But if I was to put a decimal there, now it would have 1, 2, 3, 4, 5 significant figures. Incorrect. I'm going to clear all the screen just so I have room. Same thing with this one. It has 2 significant figures because in scientific notation, this just represents zeros, in this case leading zeros, which means we have 2 significant figures. Let's look at that. 7.5 times 10 to the negative 4 means that I move my decimal 1, 2, 3, 4 places. Sorry for the bad handwriting. And I have, let's move it over here, 0.00074. 5. Let's count the significant figures here. The 7 and the 5 are significant figures. All of these up here are leading zeros. Leading zeros are never significant. So I have 2 significant digits in this number, and that's the answer I said I would get when we wrote it over here. We clear out, and then just to double check, there's 1, there's 2. These are all leading zeros. They are not significant figures. This is a trailing zero. They are, if there's a decimal, 3 significant figures. Hopefully you're feeling good about these, because you have to be able to count significant figures to do operation rules, to do math with significant figures, and find out, well, how do I round these? Now again, the point of this is this number has 3 significant figures. This number has 4 significant figures. This number has 5 significant figures. So why do we care about the number of significant figures? This one right here really drives that home. This is a really precise, this is a precision, let's go back. This is a precision instrument. So we end up with more significant figures, and more significant figures is more better if we're trying to show the accuracy of our measurement. So we have to be able to count them to be able to do math with them. And here comes the next big hurdle in this whole significant figures thing, and that's being able to add, subtract, multiply, divide with significant figures to figure out how we should round our answer so we end up with the exact same answer as everybody else in the world. That's the next video. I hope you watch it. I hope you learn more with me, and I hope maybe you click on some of the links or stuff down in the description. Come over to Beals Science, bealsscience.com, Beals Science School. All sorts of stuff going on. And my whole goal here is just to convince you to keep on learning.